Alright, so this is actually topic 2.2. Let me put over here. So topic 2.2. So graph of a function. I was too lazy to actually edit this Beamer file. So it is over here in order to determine. So if we have a graph and we want it to determine from the graph itself whether or not whatever that we sketch is a function or not, what you can do is you can actually draw a vertical axis. So vertical axis is a line that is parallel to the y-axis. This is a vertical line. So vertical in Malay is menegak. So line yang menegak, horizontal means melintang and vertical is menegak, right? So when you draw a vertical line, so if it actually cuts more than one point, so this is explanation. If the line cuts the graph at more than one point, then the graph is not a function. So the condition is that when you draw a vertical graph, so it has to cut at only exactly one point. So let me put over here. So function, it's going to be the opposite. So it's going to only cut at one point. So if it cut at more points, and automatically that is not a function. 1 point, not 1 point. Okay, so graph of a function. Okay, this is going to be the example. For example, if I have a function that looks like this, so this is my graph and I want to test whether or not this is a function, all I have to draw is a vertical line that looks like this. When I draw the vertical line, I find the intersection between my line and also the graph. And here, this is going to be the intersection. It is exactly at one point. So we clarify that this is indeed a function. So that is how you do. You want to know a graph is a function or not just based on the graph itself. So, and for this one, what happened is that when I draw a vertical line, so this is my vertical line, and that is my graph. So when I observe, my line actually going to intercept the graph at 2 points. This is the first point, and that is the second point. So that is a hint that this is not a function. So this is also known as the vertical line test to verify. So whether or not whatever that you had is a function. Okay, first of all, let's have a look at linear function, how the graph looks like. So this is going to be the general form of a linear function, as I mentioned to you before. So when you have a variable, it could be x, it could be anything, as long as your variable is raised to the power of 1. So automatically that is going to be a linear function. Or sometimes we could also see it in the form of y equal mx plus c. It's the same. So whatever variable that is next to, whatever constant that is next to the variable, or a for this case, so m and e actually means the same thing over here. So that represents the gradient. So what is gradient? In Malay, gradient is called as being kecerunan. Okay, there are three possible values of m. So m could be greater than 0 when you have a positive gradient. So this is going to be a positive gradient. So when you have a positive gradient, so meaning that your graph is increasing. For example, this is my graph. How do you know whether your graph is increasing or not? So this is going to be the x and y axis. So you observe what happened when the value of x increases. So this is where the value of x increases. So as I go along this direction, so the line is actually going up. So that is telling us that yes. So what happened is that this is a positive gradient, that my function is actually increasing as the value of x increase. And we could also have the second case is when your gradient is less than 0, means that you can have a negative gradient. So negative gradients mean that as the value of x increase, your function actually decrease. It's going to be the other way around. And this is going to be my x direction, and this is going to be my y direction. And what happens is that if I go down that way, as the value of x increases, so my graph is actually going down. So that is actually a hint to you that this graph has a negative gradient. And the last type is when it is not negative and it is not positive, but the case that you have that your gradient is going to equal 0, meaning that it's not increasing, it's not going up, and it's not going down as well. So what happens is that your graph is going to look something like this. Okay, so it could be a graph that is a horizontal line like this. For example, this could be a value of 2 and so on. Okay, for example, when do you come across this kind of graph? For example, if I have y equal 2, or if I have y equal 10, This is how the graph looks like. If y equal 2, this is going to be equal 2. So if y equal 10, this is going to equal 10 and so on. So for example, if I have y equal 10, it's going to be somewhere up here. And this value right here is going to equal 10. So that is how it goes. Okay. So when you have a graph of constant, so what happens is that the gradient is equal 0. Because remember, when equal mx plus c, so when this is 0, automatically you will only be left with the c value. And there's another thing that I would like to verify to you about when do we use y, when do we use fx, and so on. So actually, when we sketch, what does x and y represents, or fx? If I have a function of y equal x squared, so let's put x instead. It's going to be easier for me to sketch. If I have y equal x plus 2, so what are going to be my variables? For this case, my variables is going to be y and also x. So when I sketch this function, having this different variable is going to influence only the axis. So this is going to be x and this is going to be y. And my graph is going to be the straight line because the gradient is equal 1, okay? And the intercept point is going to be at 2. Okay, now I'm going to change the graph slightly. Instead of using y, I'm going to be using fx. So fx is equal x plus 2. So if you notice, these two are exactly the same thing. The only difference is that for this one I'm using y and this one I'm using f of x. So what changes is going to happen when I actually change y to f of x? Actually, nothing changes except for the axis. So this is still going to be x. So the only difference is that now my axis is going to be f of x. But in terms of the graph, it's still going to be the same. This is still going to be 2 and the graph is still going to be increasing. Only the axis is going to be different. All right, so whether it's going to be y or f of x, so don't be scared by it. Don't get intimidated by it. So just the axis differs. Okay, that is going to be graph of a linear function. So when you sketch a graph of a linear function, there are two things that you have to be mindful of. So the first is going to be the gradient. So whether your graph is going to be going up or going down. And the second thing will be the intercept. Intercept will be x-intercept and also y-intercept. So this is intersection at y-axis. So it's called as being the x-intercept. And this is intercept at y-axis. So it's called as being y-intercept. So when you sketch a linear function, you should have this element that your gradient should be correct, whether it's going to be increasing or decreasing. You should have x-intercept and y-intercept spotted on the graph. Okay, that is going to be a linear function. So now let's have a look at quadratic function. So this is going to be the general form of quadratic function. I did mention this to you before previously when we have a look at 2.1. When a is greater than 0, it's a mild graph. A is less than 0, it's a sour graph. Okay, and the important features of when you want to sketch a quadratic graph, what should you have? When you have a greater than 0, you should have a minimum point. So you have to calculate where is the minimum point, then only you can sketch this. And you also need to find what is going to be the x-intercept and if there is any y-intercept. Okay, if there is any y, then you should put the intercept. If there is no y-intercept, then no need to. And for this case, the minimum point is the same as the y-intercept, only for this particular case. So that is not going to be always the case. And for this one, when a is less than 0, so this is my maximum point, and this is going to be the x-intercept. But for this case, also the maximum point is the same as the y-intercept. But if they are not the same, you have to find what is going to be the y-intercept. And this is going to be the value of the y-intercept, always the case. So this is y-intercept value. You don't have to calculate that. Simply take the value of c. For cubic function, so cubic function is when you have the highest power of your variable is raised to the power of 3. You also have two cases. When your a is greater than 0 and it's less than 0. So basically this is going to be the shape. So it's going to be like this when you have a greater than 0. And it's going to be on the opposite direction when a is less than 0. Okay, so the features that you have to spot when you draw for cubic function is going to be two things, which are going to be the intercepts. So you have to find x-intercept and also y-intercept, then only you can sketch a cubic function. And the last one is going to be the rational function. So the rational function is that when you have a function px at the top, qx at the bottom, so that is called as a rational function. For example, I can have x plus 1 over x plus 2. So this is an example of a rational function. Okay, for the case of rational function, you have to be mindful about the asymptotes. So what is asymptotes? So asymptotes is a straight line that if the graph of a function approaches a straight line but doesn't cross the line is known as an asymptote, for example. So when I sketch the graph, so it looks something like this. Okay, this is my axis and I did the sketching. So when I sketch, so my graph actually look something like this. So it approaches the line. So the line I'm referring to, these two lines right here. So it approaches the line, but it doesn't cross at all. It goes close to the line, but it doesn't cross. So that is known as an asymptote. There are three types of asymptotes. So asymptote, it could be horizontal. So this is an example of horizontal asymptote. Or it could be vertical. This is an example of vertical asymptote. Or it could be oblique. Oblique means like it's going to be in terms of an equation that looks like this. So this is going to be in terms of y equal mx plus c, that will be the equation. But for the vertical one, this will going to be x equals something, and this is going to be a graph of y equal something. So those are going to be asymptotes. Later when we sketch for rational function, then I will show you how do we actually find for asymptotes. And this is what I mentioned before, like when you want to sketch each of this graph, what do you need? Okay, for linear function, you need x and y-intercept. Quadratic function, you need minimum, maximum point, y-intercept, x-intercept. Remember, this is the formula that I gave to you before. How do you find the x and y coordinates? And for the case of quadratic functions, you also need the x and y-intercept. And for rational function, you need to find the asymptotes. So when you have this element, straight away you can sketch the function.